Chapter 6, Section 2, Energy Practice. A 40-kilogram child is on a swing that is attached to ropes 2 meters long. Find the gravitational potential energy associated with the child relative to the child's lowest position under the following conditions. A. When the ropes are horizontal. B. When the ropes make a 30-degree angle with the vertical. And C. At the bottom of the circular arc. So the first thing you want to do in any problem like this is draw a picture so you can see where everything is and everything that you need to find. This is the top of the swing right here, and we'll have the child hanging down on a 2-meter rope. So that's the basic outline, and then you want to add the specific parts that you need to find. So for part A, the ropes are horizontal, so we'll draw that right there. And since the ropes are 2 meters long, the child is 2 meters off of the ground. Part B, the ropes are at a 30-degree angle with the vertical, so we'll draw that right there with the 30 degrees inside of the angle. And then the child off the ground. As you can see, the child is slightly elevated off of the ground, so we'll draw a little H right there for the height that we need to find. And then for part C, the child's at the bottom of the circular arc, so that's just right here. And you want to label everything on the picture so it's very clear. So for part A, we're just going to use the potential energy to the gravity formula, which equals mass times the gravity constant times the height. So for that, we have a given mass of 40 kilograms times the constant of 9.8 times a height of 2 meters. And when you plug that into the calculator, it comes up with an answer of 784 joules of potential energy. Part B is a little bit more involved, so we're going to draw another picture of just the Part B section so it's very clear and easy to see. We have a 30-degree angle with a vertical, and the child is slightly elevated off of the ground. That's a height we'll have to find. So the total height from the top of the swing to the bottom of the ground is 2 meters, and the length of the rope is 2 meters. So to find, we're going to use the cosine formula. Cosine of 30 degrees equals adjacent, which we'll label x, over the hypotenuse of 2 meters. And when you solve for x, it equals 1.73 meters. So that's this adjacent part of the triangle, and we will subtract that from 2 meters to find that distance from the ground. So 2 meters minus 1.73 meters equals the height, and when you solve for it, it is 0.27 meters. So we'll take that height and plug it into the same formula as part A for potential energy due to gravity. So once again, we have a mass of 40 kilograms times 9.8, and this time multiplied by 0.27 meters. So when you plug that into the calculator, it equals 105 joules of potential energy. And now finally, for part C, we'll refer to the picture we drew earlier. The same formula as well. Potential energy due to gravity is mass times gravity times height, which equals 40 kilograms times 9.8. And this time the child is not off the ground at all. He's level with the ground, so the height is 0, which means that in total the child has 0 joules of potential energy.